Imagine 10,000 strangers, each writing in their own private notebook. None of them talk to a leader. None of them vote. Yet somehow every notebook ends up identical down to the last comma. That's not magic. That's Bitcoin. Today we unpack how thousands of computers trusting no one agree on exactly the same ledger. Traditional payment systems solve this with a boss. Visa, your bank, a clearing house, all sit at the center. Every transaction passes through them. They declare what's true. Bitcoin throws that model out. There's no center. Yet every full node, meaning every computer running the full Bitcoin software, ends up holding the identical blockchain. Satoshi Nakamoto's insight was that consensus doesn't need to be declared. It can emerge spontaneously when independent actors all follow the same rules. Emergent consensus rests on 4 parallel processes. 1. Every node independently verifies transactions. 2. Miners independently package transactions into new blocks using proof of work, a computational puzzle. 3. Every node independently validates those blocks. 4. Every node independently selects the chain with the most accumulated work. These 4 processes run simultaneously, not in sequence. Each node executes them in isolation, following identical rules. The astonishing result: no coordinator, no vote, yet every honest node converges on the same blockchain. Of these 4, transaction verification is where the network's immune system lives. Watch a single transaction's journey. A wallet broadcasts a payment to its nearest neighbor, Node A. Node A doesn't blindly forward it. First, Node A runs the transactions through a strict checklist. Only if every check passes does Node A relay it onward to nodes B, C, and D. Every node at every hop repeats this verification. Here's the checklist every node applies. 1. Syntax and data structure are valid. 2. Inputs and outputs are non-empty. 3. Transaction weight fits within block limits. 4. Output values fall between 0 and 21 million Bitcoin. 5. Log time. The earliest time a transaction can be included is satisfied. 6. The count of signature operations stays under the limit. 7. The referenced UTXOs, meaning unspent transaction outputs being consumed, actually exist. 8. If spending a Coinbase, the miner reward transaction, it has at least 100 confirmations. 9. The sum of inputs is greater than or equal to the sum of outputs. 10. Every script validates successfully. Now the punchline. Suppose someone broadcasts a malicious transaction, say, spending coins they don't own. The first node receives it. The checklist runs. Rule 7 fails. The referenced UTXO doesn't exist. The transaction is dropped. It is never forwarded. It never reaches node B, never reaches node C, never reaches the rest of the network. Invalid transactions die at the first hop. The network self-cleans automatically without anyone in charge. Valid transactions that survive verification land in something called the mempool, short for memory pool. Each node maintains its own mempool, a waiting room of valid but unconfirmed transactions. Miners draw from these mempools when building the next block. Note the key word, each node's own mempool. They aren't identical across nodes, and they don't need to be. What matters is that every transaction inside any mempool has already passed the same strict rules. Step back and see the design. Multiply this discipline across all 4 pillars and across thousands of nodes. Miners can't force invalid transactions on the network because every node re-verifies. A rogue node can lie, but its lies get rejected at the next hop. There's no vote because there's no need for one. Identical rules applied independently produce identical results. Bitcoin replaces trust in institutions with trust in rules. The rules are public, deterministic, and enforced by every participant on every transaction. This pattern, emergent order from local rules, isn't unique to Bitcoin. Ant colonies coordinate without a queen issuing orders. Markets set prices without a central planner. The internet routes packets without a master switchboard. Bitcoin is the same idea applied to money. There's no boss, there's no vote, there's no moment when consensus is declared. There's just math and a handful of simple rules repeated by thousands of machines who have never met, who don't trust each other, and who together produce a single shared truth.